My name is Dr. Ganesh. Today I am going to discuss about the Senior Interphysics Model Paper 1 IPE, in which question number 1. What is dispersion and which color will get relatively more dispersed? This was a question given to us. So therefore, in the case of dispersion here, a prism onto which a composite white light is made to incident. A composite white light is made to incident on one surface of a prism, and this has been now after refraction splits up into various colors. Among them, the lowest one is violet, and the topmost is your red. The remaining colors will be spread over here. The process of splitting of white light into its constituent colors by the prism is being called as dispersion. Among them, violet is going to be now deviated most, and that of the red. Suppose if the prism is not there, the light ray might have gone in the straight line. If the prism is not there, the light ray might have gone in the straight line due to the phenomena of rectilinear propagation. So due to the prism here, the violet light ray has been now deviated from the initial position to this one. This is called as angle of deviation, and the red light is being deviated from here to here, called as angle of deviation for the red light. So this will call as delta R, and this will call as delta V. So when we compare these two here, delta V will be much greater than that of the delta R. So therefore here we can confirm that violet light is being deviated more than that of the red light. The reason for this one is angle of deviation for small angle prism is given by the formula D will be equal to mu minus 1 into A, where D is called angle of deviation, mu is called refractive index, and A is the angle of the prism. D is the angle of the angle of deviation, mu is refractive index, and A is the angle of the prism. Now from the Cauchy's relation, mu is now inversely proportional to wavelength. Therefore, now we can confirm that angle of deviation is now inversely proportional to wavelength. Larger wavelength, smaller deviation. Red color will have larger deviation, therefore larger wavelength, smaller deviation. Whereas violet light will have the less wavelength and larger deviation. Hence, angle of deviation for the violet light is much greater than that of the red light. Now the second question is distinguish between ammeter and the voltmeter. So let us take up the question number 2. That is, we are going to distinguish between the ammeter and voltmeter. Let us write these discussions separately. The first one I'll go for the ammeter, and second one is a voltmeter. So now we are going to compare the ammeter and voltmeter. Basically, by definition, ammeter is a device used to measure the current, and voltmeter is a device used to measure the potential difference across the element. The element may be a resistor. So therefore here, first let us see what is an ammeter. Ammeter is a device used to measure the current in a given circuit. Whereas in the first point here now, voltmeter is a device used to measure the potential difference. potential difference, right? The second point here, in the case of the ammeter, a galvanometer can be converted into ammeter by connecting a low resistance called as shunt resistance in parallel. So therefore, let us assume this circle with G indicates the galvanometer and G also indicates its resistance. G also indicates the resistance. So for this galvanometer, I am going to connect a low resistance called as shunt in parallel. Called as low resistance shunt in parallel. So S stands for shunt, which is very small when compared to that of the resistance of the galvanometer called as G. So therefore, this instrument now will works as an ammeter. This instrument will now works as an ammeter. Hence, it is going to be now denoted by a letter called as A. Galvanometer, when shunted with the small resistance or shunted, so therefore converts into ammeter. Ammeter is going to be now shown like this. When we go back to the voltmeter, let us see. In the case of voltmeter, a galvanometer can be converted into voltmeter by connecting high resistance in series. High resistance in series. So this is your galvanometer, as we have discussed. For that I am going to connect a high resistance in series. The complete instrument will be called as voltmeter. That voltmeter will be shown as circle with a symbol V. So now this is the comparison here now. Galvanometer can be converted into ammeter by connecting shunt in parallel. Here galvanometer can be converted into a voltmeter by connecting high resistance in series. Okay. The effective resistance of the R effective, we can call R effective of the galvanometer, effective resistance of the ammeter is given by the formula G into S by G plus S, because it is R1 and R2 are in parallel. Likewise, G and S are parallel. Since G and S are parallel, we are going to use the formula R1 R2 by R1 plus R2. We will get GS by G plus S. This effective resistance will be lesser than the shunt resistance. Lesser than shunt resistance. When we go back to the voltmeter, since I am adding high resistance in series, the effective resistance will be added up. Effective resistance now will be equal to G plus R, and this value will be greater than R. This value will be greater than R. Okay. The fourth point here, always the ammeter is being connected in series. Always, once the instrument has been constructed, that instrument is being connected in series to measure the current. And here, in the case of voltmeter, it will be always connected in parallel across the any element to measure the potential difference. Then the fifth point here now, the ammeter, if it is an ideal ammeter, the effective resistance will be equal to 0. Effective resistance of an ammeter will be equal to 0. Whereas in the case of the voltmeter, effective resistance R effective will be equal to, it is infinity. Effective will be equal to infinity. So these are the points we have to cover for the question number 2, distinguish between the ammeter and voltmeter. Now the question number 3 says, state the Gauss laws in electrostatics. So for that one, question number 3, let us assume there is an uniform electric field as shown here. In this electric field denoted by letter called as E, let us say a closed region has been now selected, called as closed path. Let us say that closed path will be as shown by the in the diagram, as shown in the diagram. In this closed path, in this closed one, what is the flux which is now coming out for this given area? That is being called as phi. That is being called as phi, where phi is a flux which is now coming out through the given selected area. Given selected area. This flux is equal to 1 by epsilon naught times the net charge enclosed by the area or enclosed by the closed curve. So therefore, the flux which is coming out through the closed surface area in an electric field, the flux which is now coming out through the closed surface area in an electric field will be equal to 1 by epsilon naught times the net charge enclosed by the boundary. Here epsilon naught is called the permittivity of the free space. And Q net is a net charge enclosed by the boundary. Q net is being called as net charge enclosed by the boundary. So therefore, for a given question, you just explain the diagram, explain the statement and just give the formula, which completes your question number 3. Now let us discuss about the question number 4. The question number 4 says that what is the magnetic moment associated with a solenoid? What is the magnetic moment associated with a solenoid? So therefore here we have to write down the expression for the magnetic moment of a solenoid. The magnetic moment of a solenoid is given by the formula M is equals to N into I into A, where N is number of turns, where in this number of turns, and I is the current through the solenoid, A the area of the solenoid, area of cross section of the solenoid, and its units are M stands for the magnetic moment. The magnetic moment is now given by the formula NIA. N is the number of turns, I is the area, I is the current, and A is the area of cross section. Number of turns, current, and area of cross section. So now if we see the units here now, number of turns, no units, current will be expressed in ampere and area will be expressed in meter square. Current is expressed in amperes and area will be expressed in meter square. So therefore, number of units will be, it is ampere into meter square. It is a vector quantity. So magnetic moment given by the formula M is equals to NIA. Now the question number 5. In the question number 5, Question number 5. He says that a bulb was rated as 220 watts. A bulb was rated as 220 watts. Therefore, it is means power of the bulb now will be equal to 220 watts. Similarly, it is now rated at what voltage now? It is rated at 220 volts. So therefore, the potential difference can be applied across it, at which its power will be 220 volts is even 220 volts. So at this particular voltage, the rated of the bulb will be equal to how much? 220 watts. Now in this case, he is asking to calculate the resistance of the bulb. So therefore, capital R we are supposed to calculate, which means he has given power, he has given potential difference, and he is asking the resistance of the bulb. But these three terms are being related for a given bulb as being shown here. So power, electrical power consumed by an instrument is given by the formula current into voltage. Electrical power consumed by an instrument is given by the formula current into voltage. I is a current and V is a potential difference. And from Ohm's law we know V is equals to IR. Since V is equals to I into R, I into I will become I square into R. So therefore power will be equal to, it is I square into R. Next is even I can replace, I is replaced by V by R. If I is replaced by V by R, I will get V square by R. So therefore, in the given problem, he has given power, voltage, and we want resistance, which means current is not required. So power we require, term, voltage is required, and even resistance. Power, voltage, resistance. Therefore, third concept will be used in calculating the resistance. Therefore, power is now given by V square by R from the above expression. Now we are supposed to calculate the value of R. Hence, let us interchange the terms now. R will be equal to V square by P. And V will be equal to how much? 220 volts he has given. Therefore, 220 into 220 divided by power also will be equal to 220. These two will get cancelled. Therefore, resistance of the wire now will be equal to 220 ohms. Resistance of the wire. Now, the question number 6 is the applications of the microwaves. Applications of the microwaves, question number 6. Microwaves are the waves, electromagnetic waves, whose wavelength is short. They have the small wavelength or shorter wavelength. Shorter wavelength. Being the shorter wavelength of these microwaves, they have been used in the radar. They have been used in the radar for the navigation of the aircraft. Being the shorter wavelength of the microwaves, so they have been used in the radar for the navigation purpose. The next is they are used in the microwave oven. The concept microwave oven. In the case of microwave oven, it is basically used to raise the temperature of the foodstuff which contains water. So therefore, these are the two applications of the microwaves.